Hi, my name is Hanju Kim from Database Lab. Today I'm going to present a thesis called Translating Embedding for Knowledge Graph Completion with Relation Attention Mechanism. Before we get into the topic, we should know what is knowledge graph. Knowledge graph is a technology used to store complex structured and unstructured information. It's directional graph that consists with entity nodes and relation edges. Generally, a knowledge graph encodes structured information of millions of entities and billions of relational facts. Knowledge graph embedding is an essential part for knowledge extraction. In knowledge graph embedding, knowledge graphs are mapped to vector in vector space, like word to vector. All entity and relations are shown as continuous vector space. For illustrate, as you see on the right side, entity Arthur Cayley, London, and relation was born in are mapped into the vector. So as you can see here, this is knowledge graph that illustrated. And when we get into knowledge graph embedding, it shows like in a vector space like this. For previous knowledge graph embedding methods are try to interpret the relations among entities as translation from head entity to tail entity, and attempt to transform the entity embedding concerning the given relation for distinguishability. Also, previous researchers think the relation-related transforming should reflect attention mechanism, which means it should focus on only a part of the attributes. But this kind of approach has a problem with learning attentions. The reason is that they ignore hierarchical routine of human cognition. When predicting whether a relation holds between two entities, people first check category of entities, then they focus on fine-grained relation-related attributes to make the decision. In other words, the attention should take effect on entities filtered by right category. Figure 1 shows some examples of transformation metrics learned by Trans-R model. They are approximate to unit metrics. It means their attention mechanism do not work well. In this paper, they propose a knowledge graph embedding method with attention mechanism named Transat. Transat stands for translation with attention. This is a simple illustration of our motivation. Above is a simple prediction task. From human perspective, we usually reject entities from wrong categories. First, so car is not the option. Then we will focus on relation-related attributes, occupational skills, and choose farmer. As shown in this picture, let's consider a triple X. One's occupational skill is farming, where X needs to be determined. Intuitively, people will exclude the entity car because it does not belong to category processing the attribute occupational skill. So as you can see here, they excluded car, they discarded. And then farmer is obviously more suitable to fit into position than driver when taking the farming skill into account. They all have attributes occupational skills, but they differ from each other's on it. The driver and the farmer have many other common attributes such as wages, working hours, etc. But for this relation, we only care about occupational skill attributes, so we chose farmer. So we have two different stages for first ensuring right category and check relational attributes. Just like this paper proposed new knowledge graph embedding method called TransAt. As I told you before, it stands for translation with attention. The feature of this method is learning the translation-based embedding, relation-related category of entities and relation-related attention simultaneously, and follow human cognition for relation follows hierarchical routine, and there exists category among entities. In this model, they evaluate their model with link prediction. In a few words, link prediction process has two stages. In first stage, they will collect candidate entities from reasonable categories. In the second stage, for those possible triplet composition, they need to focus on fine-grained attribute for entity distinguish them concerning the particular relations, as we saw the picture right before. As I mentioned earlier, distinguishing entities among different categories and fine-grained difference involve all attributes at all levels. Previous models failed to learn fine-grained attention. Proposed piecewise evaluation function, where HRTR is capable head tail candidate set for relation R. PR is a projection which only keeps dimension related R. Equation one means that if head entity or tail entity is not suitable to relation R, their distance relation R is infinite. If both head entity and tail entity are suitable for relation R, their distance to relation R is similar to Trans-E model, but only focuses on interested dimension here. Problem before how to obtain the capable candidate sets and how to set the projection function. For the candidate sets, they used k-means algorithm to aggregate all entities to some clusters and merge clusters which have head or tail entities in triples related to relation R to constitute head or tail candidate set for relation R. Considering that some relations have ORC structures, they propose an asymmetric version of scoring function. Since they hope there exists only single embedding representation for entities, they use two vectors to scale each dimension of origin embeddings on head position to tail position respectively. If both head entity and the tail entity are suitable for relation R, their symmetric scoring function became where PR is projection which only keeps dimension related to R. Omega is sigmoid function, and RH, RT are two vectors related to relation R. So experiments are carried out on public knowledge graph dataset retrieved by WordNet and Freebase corpus. All these datasets consist with training sets and validation set and testing sets which are well organized. Experiments evaluation will focus on three evaluating points: link prediction, triple classification, and attention mechanism. Table 1 is statistic of datasets. Link prediction for knowledge graph is predict the missing H or T. Link prediction for knowledge graph is predicts the missing H or T for a correct triplet HRT, as I told you before. The evaluation of task mainly contains two metrics: the average rank of correct entities, mean rank, and proportion of correct entities ranked in top 10. We simply say hits at 10. We conduct our experiments using two datasets, WN18 and FB15K, and compare with all previous existing method. Comparing, yeah. Experimental results on WN18 and FB15K are shown in Table 2 here. Transat method have the best mean rank performance on both two datasets. And on WN18 dataset, Transat approaches significantly improve all the metrics. Triplet classifications aim to make judgments on correctness of triplet HRT, which is a binary classification task. The test set of WN11 and FB13 contains positive and negative triplets. For triplet classification task, we need to learn threshold zeta R for each relation R. When judging triplet is correct or not, we just calculate the translation distance between the head entity and tail entity with respect to given relation as the score. For given triplet HRT, if its score is lower than threshold zeta R, and both our head entity and tail entity are in respective candidate sets, it will be classified as positive, otherwise negative. Experimental results on WN11 and FB13 are shown in Table 3. Transat method have the best classification performance on both two datasets. This means our approach could find the right candidate sets with high probability. Otherwise, it will obtain decidedly worse results since they merely think the triple with entity not in candidate sets are negative. I forgot to say this, but on link prediction, lower the better, and triple classification, the result is higher the better. And lastly, Figure 3 shows some attention vectors are learned by Transat model. These are some randomly selected attention vector learned by Transat model on FB15K datasets. Multiplying each entry of vector with 255 and concatenating these vectors together. Each raw is attention vector, by the way. We show them as a grayscale image. White has grayscale in value 255. Multiplying each entry of vector with 255, concatenating these vectors together. Each row is attention vector, by the way. We show them as a grayscale image. Oh, sorry, I duplicated the lines, sorry. Figure 3 demonstrates that our method can truly pay attention to a part of dimension of some relations. In this paper, in conclusion, it focuses on translation-based embedding method for the task of knowledge graph completion, which can be embedded entities and relations in knowledge graph to continuous vector. Research team found that previous method failed to learn attentions, thus they introduce a model named Transat to solve it. Specifically, they noticed that there exists a hierarchical structure among the attributes in entity, and human cognition of entity follows hierarchical routine. Thus, they propose a two-stage discriminative method to achieve attention mechanism. As we saw before, experiments shows that Transat model indeed pay attention to a part of the dimension and outperform all baseline models on triple classification and link prediction tasks. They insist that it would be used in widely for knowledge extraction and recommender systems. Thank you for listening to my presentation.